Java linked list. A linked list in Java is a linear data structure where elements are not stored in contiguous locations. Instead, each element, node, contains a reference to the next element in the sequence. This allows for efficient insertions and deletions at any position in the list. Key characteristics. Dynamic size, can grow or shrink as needed. Insertion order, maintains the order in which elements are added. Allows duplicates, can store duplicate elements. Random access, less efficient for random access compared to ArrayList due to the linked nature. Implements list and dict interfaces, provides methods for both list and queue operations. Declaration and creation. Java. Import java.utility linked list. Public class linked list example. Public static void main, string args. Linked list string names equals new linked list. Common operations. Adding elements. Java. Names.add, Alice. Names.add first, Bob, //add at the beginning. Names.add last, Charlie, //add at the end. Accessing elements. Java. String first person equals names.get, 0, / access the first element. Removing elements. Java. Names.remove, Bob, / remove by value. Names.remove first, / remove the first element. Names.remove last, / remove the last element. Iterating over elements. Java. 4. String name, names. System.out.println, name. Checking size. Java. Int size equals names.size. Example. Java. Import java.utility linked list. Public class linked list example. Public static void main, string args. Linked list integer numbers equals new linked list. Numbers.add, 10. Numbers.add, 20. Numbers.add, 30. / remove the first element. Numbers.remove first. / add an element at the beginning. Numbers.add first, 5. / iterate over the linked list. 4. Int number, numbers. System.out.println, number. When to use linked list. Frequent insertions and deletions at the beginning or middle of the list. Implementing stacks or queues. When random access is not critical. Key differences between ArrayList and linked list. Feature. ArrayList. Linked list. Underlying data structure. Array. Doubly linked list. Random access. Efficient. Inefficient. Insertion/deletion. Inefficient, requires shifting elements. Efficient. Export to sheets. Java list sorting. Show drafts. Sorting a list in Java. Java provides several ways to sort lists. The most common methods involve using the collections.sort method and implementing the comparable or comparator interfaces. Sorting with collections.sort. The collections.sort method is a convenient way to sort lists in ascending order. The elements in the list must implement the comparable interface to define the natural ordering. Java. Import java.utility ArrayList. Import java.utility collections. Import java.utility list. Class employee implements comparable employee. String name. Int age. // constructor, getters, and setters. @override. Public int compare2, employee other. Return integer.compare, this.h, other.h. Public class sorting example. Public static void main, string args. List employee employees equals new array list. / add employees to the list. Collections.sort, employees, / sort by age in ascending order. / print sorted employees. 4. Employee employees. System.out.println, employee.name plus employee.age. Custom sorting with comparator. If you need a custom sorting order, you can implement the comparator interface. Java. Import java.utility array list. Import java.utility collections. Import java.utility comparator. Import java.utility list. Class employee. String name. Int. H. / constructor, getters, and setters. Class employee comparator implements comparator employee. @override. Public int compare, employee E1, employee E2. Return E1.name.compare2, E2.name. By name ascending. Public class sorting example. Public static void main, string args. List employee employees equals new array list. / add employees to the list. Collections.sort, employees, new employee comparator, / sort by name. / print sorted employees. 4. Employee employees. System.out.println, employee.name plus employee.age. Additional considerations. Primitive data types. For lists of primitive data types, like int, double, you can directly use collections.sort, without implementing comparable. Performance. For large datasets, consider using specialized sorting algorithms or libraries for better performance. Stability. Some sorting algorithms are stable, meaning the relative order of equal elements is preserved. Others are unstable. Lambda expressions. Java 8 introduced lambda expressions, which can be used to create concise comparators. Java Hashmap. A hash map in Java is a data structure that stores elements in key-value pairs. It uses a hash function to map keys to indices in an internal array, providing efficient retrieval of values based on their keys. Key characteristics. Unordered, it doesn't maintain any specific order of elements. Unique keys, each key must be unique. Null values, can store null values for both keys and values, but only one null key is allowed. Non-synchronized, not thread-safe. Fast access, provides constant time average performance for basic operations like get, put, and remove. Declaration and creation. Java. Import java.utility hashmap. Public class hashmap example. Public static void main, string args. Hashmap string, integer map equals new hashmap. Common operations. Adding elements. Java. Map.put, Alice, 25. Map.put, Bob, 30. Retrieving values. Java. Integer age equals map.get, Alice. Removing elements. Java. Map.remove, Bob. Checking if a key exists. Java. Boolean contains key equals map.contains key, Charlie. Getting all keys. Java. Set string keys equals map.keyset. Getting all values. Java. Collection integer values equals map.values. Example. Java. Import java.utility hashmap. Public class hashmap example. Public static void main, string args. Hashmap string, integer phonebook equals new hashmap. Phonebook.put, Alice. 1 2 3 4 5 6 7 8 9 0. Phonebook.put, Bob, 987 654 3210. System.out.println, phonebook.get, Alice, / output, 1 2 3 4 5 6 7 8 9 0. Phonebook.remove, Bob. System.out.println, phonebook.contains key, Bob, / output, false. Important considerations. Hash function. The quality of the hash function affects the performance of the hash map. Collisions. Hash maps handle collisions using techniques like chaining or open addressing. Null keys and values. Be cautious when using null keys and values. Synchronization. For thread-safe operations, consider using concurrent hash map. Java hash set. A hash set in Java is a collection that stores unique elements. It's based on the concept of a hash table, which uses a hash function to map elements to indices in an internal array. Key characteristics. Unordered, elements are not stored in any specific order. Unique elements, duplicate elements are not allowed. Null value, can store a single null value. Non-synchronized, not thread-safe. Fast access, provides constant time average performance for basic operations like add, remove, and contains. Declaration and creation. Java. Import java.utility hash set. Public class hash set example. Public static void main, string args. Hash set string names equals new hash set. Common operations. Adding elements. Java. Names.add, Alice. Names.add, Bob. Checking if an element exists. Java. Boolean contains Alice equals names.contains, Alice. Removing an element. Java. Names.remove, Bob. Iterating over elements. Java. For, string name, names. System.out.println, name. Getting the size. Java. Int size equals names.size. Example. Java. Import java.utility hash set. Public class hash set example. Public static void main, string args. Hash set integer numbers equals new hash set. Numbers.add, 10. Numbers.add, 20. Numbers.add, 10, / duplicate, will not be added. System.out.println, numbers, / output, 10, 20. When to use hash set. When you need to store unique elements and don't care about the order. When you need fast lookup and removal operations. When you want to avoid duplicates. Important considerations. Hash function. The quality of the hash function affects the performance of the hash set. Collisions. Hash sets handle collisions internally. Synchronization. For thread-safe operations, consider using concurrent hash map. In Java, an iterator is an interface that provides a way to traverse or iterate through a collection, such as a list or a set, without exposing the underlying structure of the collection. It allows you to loop through the elements of a collection one by one. Key methods in the iterator interface. Boolean has next. Returns true if there are more elements in the collection to iterate over. Returns false if the iteration has reached the end of the collection. Next. Returns the next element in the iteration. Throws a no such element exception if there are no more elements. Void remove. Removes the last element returned by the iterator from the underlying collection. This method can be called only once per call to next. Throws an illegal state exception if next has not been called before remove, or if remove has already been called after the last next. Example usage. Import java.utility ArrayList. Import java.utility iterator. Public class iterator example. Public static void main, string args. / create a collection, ArrayList in this case. ArrayList string list equals new ArrayList. List.add, apple. List.add, banana. List.add, cherry. / get the iterator. Iterator string iterator equals list.iterator. / iterate through the collection. While, iterator has next. String fruit equals iterator next. System.out.println, fruit. / optionally remove elements. If, fruit equals, banana. Iterator.remove. / print the modified list. System.out.println, modified list, plus list. Output. Less. Apple. Banana. Cherry. Modified list, apple, cherry. Points to note. The iterator interface is part of the Java Collections framework and is available in java.util. Using iterator is preferred over using a for loop when you need to remove elements from the collection during iteration, as it avoids potential concurrent modification exception. The iterator interface is particularly useful when working with large collections or when you want to abstract away the implementation details of the collection. In Java, wrapper classes are a set of classes that encapsulate, or wrap, the primitive data types into objects. They are part of the java.lang package. Each of the 8 primitive data types in Java has a corresponding wrapper class. These wrapper classes provide a way to use primitives as objects when necessary, such as in collections or when working with generics. List of primitive data types and their corresponding wrapper classes. Primitive type. Wrapper class. Byte. Byte. Short. Short. Int. Integer. Long. Long. Float. Float. Double. Double. Char. Character. Boolean. Boolean. Key features of wrapper classes. Boxing and unboxing. Boxing, the process of converting a primitive type into its corresponding wrapper class object. Int number equals 5. Integer wrap number equals integer.value of number / boxing. Unboxing, the process of converting a wrapper class object back into its corresponding primitive type. Integer wrap number equals 5. Int number equals wrap number.int value / unboxing. Autoboxing and auto-unboxing. Java automatically handles the conversion between primitive types and their corresponding wrapper classes. Integer wrap number equals 5 / autoboxing. Int number equals wrap number / auto-unboxing. Immutability. Wrapper class objects are immutable, meaning their values cannot be changed once they are created. Utility methods. Wrapper classes provide various utility methods for converting between types, parsing strings, comparing values, etc. Example methods. Integer.parseInt, string s converts a string to an int. Double.value of, string s converts a string to a double object. Boolean.value of, Boolean b returns a Boolean instance representing the specified Boolean value. Character.isDigit, char ch checks if the provided character is a digit. Usage in collections. Primitive types cannot be used in Java collections, like ArrayList, Hashmap, but wrapper classes can. ArrayList integer list equals new ArrayList. List.add, 10, / autoboxing. Example usage. Public class wrapper example. Public static void main, string args. // primitive type. Int number equals 10. // boxing, converting primitive to wrapper. Integer wrap number equals integer.value of, number. / autoboxing. Integer auto-wrap number equals number. / unboxing, converting wrapper to primitive. Int unboxed number equals wrap number.int value. / auto unboxing. Int auto unboxed number equals auto wrap number. / using wrapper in a collection. ArrayList integer numbers equals new ArrayList. Numbers.add, 5, / autoboxing. / displaying elements. 4, integer number, numbers. System.out.println, number, / auto unboxing during printing. Output. Why use wrapper classes? Collections. Wrapper classes are required to store primitive values in data structures like ArrayList, Hashmap, etc. Utilities. They provide utility methods for converting and manipulating data. Object-oriented programming. Wrapper classes enable the use of primitives where objects are required. Default values.